Okay, I thought I would do, this is Calculus section 2.3, and problem number 69 asks us to find the tangent line to the curve at the point. Well, here's the function. They actually graph it for us, and they tell us these are called the witches of Agnesy or something like that. Okay, so it's 8 over x squared plus 4, and your point that they want you to find the point of tangency to is 2, 1. Now, if they want an equation of a line tangent to this function at that point, I know that I'm going to need to write the equation of a line, and I can already see because they gave me a point, and it's not the y-intercept that we're going to need. This y minus y1 is m times x minus x1. I'm sorry about that being hard to read. And remember, on your point that they give you, this is your x1, and this is your y1. So I can already go ahead and plug in y minus 1. I need the slope, and it's x minus x1 is 2. So if I just take the derivative of this, I'm going to be able to find the equation of the slope. And then I'll plug in, once I get the equation of the slope, remember the derivative is a function, it's not a number, it's just a function. Then I can plug in x equal 2, which is really given to me in the point that they gave me, and find the slope at 2, okay? So now if I'm going to rewrite this, I may want to, I could rewrite this, but I don't know. It might be easier just to go ahead and use the quotient rule. That's what I'm going to do here. Okay, so if I'm going to take the derivative, I could denote it that way. If you remember, the quotient rule says low d high minus high d low over low squared, if we want to try to find words to say it so we're not always having to look that up. Now the x squared plus 4 squared is the low squared, isn't it? The low, d high, would mean take your low function, x squared plus 4, your function in your denominator, and multiply it by the derivative of the numerator, that's the high, d high part. The derivative of constant is 0. Yay, that all just became 0. Then I got to subtract high times the derivative of the low. Well, the derivative of x squared is just 2x. So this is going to be pretty easy in the end because of that constant on top. It would be negative 16x over x squared plus 4. This is the equation for the derivative, which is the equation of the slope. It's the rate of change of the equation. But it's at the rate of change. It's a function. It's not a number, and I don't plug in a whole equation up there for my slope. If I want to, what I can do now to find the slope, though, is take the x that they gave me and plug it in. So I'm going to evaluate f prime of 2, because that's the x they gave me was 2. So we just plug in 2. 2 squared plus 4 squared. That's negative 32 over 2 squared is 4 plus 4 would be 8. Okay, and then I got to square it. So that's negative 32 over 64, and that reduces to negative 1/2. Remember, we really don't like decimals so much. Let's use fractions where at all possible. Here's my equation of my tangent line at the point 2, 1. We just fill in the slope once we find it. Problem number 73 asks us to find the places where a horizontal tangent line, where there's a horizontal tangent line to this function or in its graph, okay? Now, if you think about it, a horizontal tangent line, what does it mean to be a horizontal line? What is the slope of a horizontal line? The slope is 0 of a horizontal line. I'm looking for places where the slope is 0. Now, how am I going to do that? Well, I've got a function. If I take the derivative, that gives me the slope, doesn't it? So I'm going to take the derivative here. And this is going to require the quotient rule. Okay, so I know on the bottom is low squared, and the reason I write that in first is that helps me remember to start with a low also on top. So low, the function in the denominator, is x minus 1. Low d high, derivative of the numerator, or the high part, would be 2x. Minus, so low d high minus high d low, so high is x squared. The derivative of the denominator would just be 1, yay. So f prime of x is equal to, I've got to simplify there on the top, 2x times x is 2x squared. 2x times negative 1 is minus 2x. And then minus x squared, all over x minus 1 squared. Now if I simplify that, 2x squared minus x squared leaves me with just x squared. So these two combine to just be x squared. And then I've got minus 2x over x minus 1 squared. This is the slope, but I want the slope to be 0. That will tell me where there are horizontal lines, horizontal tangent lines when I will graph this function. So what I'm going to do is take the slope and set it equal to 0 because a horizontal line has a slope of 0. So x squared minus 2x over x minus 1 squared equal to 0. Now if you think about it, the denominator really doesn't come into play here because what determines if the function is going to be equal to 0 is the numerator. So what I really got to do is set the numerator equal to 0. So what I'm looking at is x squared minus 2x is equal to 0. So x squared minus 2x equals 0. If you look at that factors, you can take an x out and you get x minus 2 is equal to 0. So if two things multiply to get 0, we're just solving a quadratic equation here. Either the first factor x is equal to 0 or the second factor is equal to 0. So x equals 0, or if I solve this one, I get x equal 2. So there are two places on this graph where there are horizontal tangent lines, things that have slopes of 0. And I found it by setting the derivative equal to 0 because the derivative is the slope. Alright, so at x is 0 and x is 2, but that's not really the whole story there because you know what? I want to know what the point is. I don't want to really just say at x equals 0 and x equals 2. I could do that, but if I want to really give a thorough answer, I should go back in and plug those into the function, the original function, and tell the y value that goes with them. If I plug in 0, I get 0 squared, which is 0 over negative 1, so it's, let's see, x squared over x minus 1, f of 0 would be 0 squared, 0 minus, okay, so it's just 0. And then if I plug in 2, what is f of 2? It's 2 squared over 2 minus 1, which would be 4 over 1, which would be 3. Make sure I did that right. 2 squared is 4. 2 minus 1 is 1. 2 minus 1 is 1. Okay, so 4 over 1 is 3. So at the point 2, 3, here are my solution points right here. Those are the places on that curve where it has a horizontal tangent. And then problem 83 would be a good one to look at, I guess. 83 wants you to find the rate of change of the area with respect to time. And they give us this, I think it's a rectangle or something. It has a length of 2t plus 1. And it has a height of square root of t. So if I want to find the area is just length times width, or length times height, base times height, however you want to say it. But your area is going to be these two things multiplied together. I'm going to write the square root of t first just because I want to, and I'll just put 2t plus 1. Now I know if I'm finding the rate of change, that means take the derivative. Remember, the rate of change is the slope, and the derivative is the slope. So all those things mean the same thing. Rate of change and derivative and the slope are all the same thing. So I'm going to write this. I'm going to rewrite my function just so it's going to be easy to take the derivative of, because I can see I'm going to use the product rule here. If I take the derivative of a with respect to time, with respect to t, and again, this t is just saying that's the variable I'm taking the derivative with respect to, and they told me that. They worded it, if you read the book. The rate of change with respect to time means that we're taking the derivative with respect to time, which is t. All right, so I need to take the derivative of this. It's the product function, so we write the first term down, t to the 1/2, and we multiply it by the derivative of the second term, which is just 2. The derivative of 2t plus 1 is 2. And then I'm going to add in the second function, 2t plus 1, times the derivative of the first function. If you take the derivative of t to the 1/2, you drop the 1/2 out front, you write your t, and then you subtract 1. 1/2 minus 1 would be negative 1/2. Okay, hard to read, but hopefully you caught that. So I just need to simplify that. I'm going to go ahead and anytime I see a t to the 1/2, I'm going to write it as the square root of t now, just to kind of change it back into the form in which they gave it to me. That's 2 times the square root of t, because t to the 1/2 is the square root of t. Now I've got, let me write this other part down. I got 1/2 t to the negative 1/2 times 2t plus 1, and that's going to take a little more thought to simplify, so I'm going to go a little slower here. So 1/2 t to the negative 1/2 times 2t. 1/2 times 2 is 1. If I multiply t to the negative 1/2 times t, remember there's a 1 as an exponent on the t, I add those exponents. Negative 1/2 plus 1 would be t to the 1/2. Oh, there's another square root of t in there. Maybe I want to write it that way as I go. Okay, just so I can save some space here. Now I got to multiply 1/2 t to the negative 1/2 power times 1, which is just giving me the same thing back. 1/2 t to the negative 1/2. Well, if I think about that, that means that the t to the 1/2 goes on the bottom, if we need to break this apart into smaller pieces. So that ends up being 1 over, on the bottom it's 2 times the square root of t. Okay, I'm just going to mark the whole thing out and rewrite it just because I don't want you to get confused about what I meant there. Alright, so if I have 2 square roots of t and somebody gives me another square root of t, don't I have 3 square roots of t? That combined these two terms. And then I have plus 1 over 2 square roots of t. And that would be, if I haven't made any mistakes, which, you know, never know if I do or not, that would be my my derivative there. That would be dA dt, the rate of change of area with respect to time is how we can say that.